All right. This is lesson 7.3 out of the Rolf book, and it's compound events, union, intersection, and complement. So the first thing is complement. Basically, if you know one part of a probability, the complement to it has to add up to 1. So if this is 40, then this is 60. If this is 90, this is 10. It has to add up to 1, the complement. So the probability the person selected at random likes hamburgers at a local restaurant stands at 30%. So that would be 30%. It says find the probability the person selected at random does not like the hamburgers. So that would be the complement. So that would be 70%. So the answer to the problem is 70% because it's the complement to add up to 1. So there's the answer to this one. Mutually exclusive is an important concept in probability. And basically, mutually exclusive means that there's no overlap between the two sets. So there's no connection between these two sets. They're completely apart from each other. So we have to go through here and just identify yes or no whether they are mutually exclusive. Selecting a boy from a group of students, selecting a girl from a group of students. So in a probability book like this, you're either a boy or a girl. That's the way that this book is set up. So it's either you're one or the other. So that would be a yes. Drawing a king from a deck of cards, drawing a face card. Well, a king is a face card. So there's overlap between the two. So that would be no. Selecting a student who is taking English and selecting a student who's taking math. Well, you could take math and English at the same time. So those are not mutually exclusive. Selecting a number from a multiple of 5 and a multiple of 7. Well, if you count by 5s, you hit 35. If you count by 7s, you also hit 35. So 35 would be the first time that would happen. The next time it would happen would be at 70. And the next time it happened after that is 105. So these are not mutually exclusive because they overlap each other. Okay, a person having a birthday in February, a person having a birthday on the 30th of the month. There are no 30 days in February, so those things are mutually exclusive. There's no overlap between the two sets. All right, example 3 here. It says, now here's where we can use we can use that complement idea to help us out. All right. I need more water, faster, thirsty. There we go. All right. So it says 2 people are selected at random from a group of 8. 2 people are selected at random from a group of 8 women and 10 men. Find the probability that both are men or, so we got to do an or, so we got to add both are women. So there's 18 total people. So part A, it would be C, 18, and we're choosing 2. And we want 2 men, so that would be C, men is 10, 10, comma 2, plus C, 8, comma 2 would be 2 women, and then over C, 18, comma 2. So you figure out this answer and you add this answer together, and that would be the answer to this. Just for shortening the video, I'm not going to go through the calculations. That you can figure that part out. But that would be then or, so we're going to add them together, and it's a combination because you're just selecting. There's no order to it. You're just selecting 2. Okay, now part B, at least one woman. Well, there's 3 different situations here. You can have no women, you can have 1 woman, or you can have 2 women. That's the whole scenario, right? You can have 2 if you're just picking out, 2 people out of the 18. So you can have 0 women, 1 woman, or 2 women. So we want to know at least 1 woman. Well, that would be 2 and 1, 1 and 2. Or what we can do is we can do 1 minus the probability of 0 women. Okay, so that would be the whole thing is 1. And if we subtract out 0 women, we would get the probability of 1 and 2 women. That shortens the problem. So it's 1 minus, and then we got 18, comma 2. And then no women would be 2 men. And I just figured out 2 men, didn't I? 2 men is right there. C, 10, comma 2. So that totally shortens the problem. So it's 1 minus no women is the same thing as doing 1 woman and 2 women and then adding those probabilities together. All right, this is kind of the same idea here. We have a pen holder. It holds 10 pens, 3 of which do not write. If 3 pens are selected at random, find the probability that at least one writes and at least one does not write. So 1 writes and 1 does not write. Okay, so A, at least 1 that writes. So you could have 0 that writes, and we're picking out 3 pens. 0 could write, 1 could write, 2 could write, 3 could write, right? So if I do this, right, it's separate. It's going to be the probability of 1 minus the probability of none of them writing. And that would be the same thing as adding the probability of 1, 2, and 3 writing. So at least 1 means it could be 1, it could be 2, it could be 3. But 1 minus no writing, it would be the same answer. So no writing, there are 10 pens, so it would be C 10, comma 3. It's a combination because you're selecting 3 pens out. And then C, all 3 would be C 3, comma 3, which is just 1. So it'd be 1 minus 1 over that answer right there. For part B, you are doing the same idea, but it's 0 that does not write, 1 does not write, 2 does not write, and 3 does not write is a slightly different problem, same concept. So we can do 1, 2, and 3, add those together, or we can do 1 minus the probability of none of them writing. So we still are selecting 3, so it's C 10, comma 3, and we want none that do not write, which means they all have to write. There are 7 writers, and we are selecting 3 out of that. So none of them do not write, which means they all write. So they all write, they 2 write, 3, well, 0 write, no. Yeah, 3, 2, 1, 0. 3 write, 2 write, 1 write, none write, which means all 3 of them do not write. Wow, that's kind of confusing. So you get this answer over this answer, subtracted from 1, and that is the answer. Okay, the 5th problem is going to be a circle situation here. So I have 100 children. So my universe is equal to 100. We have 2 circles, and we have overlapping, so it's not mutually exclusive. What are we doing with the children? We have initials. First initial R, second initial R. So I'm going to do a little r for first initial because it's the baby initial, and then capital letter for the last name. Okay, so again, you want to read through this backwards. 6 have both the first and last initial. So you would put a 6 here. 11 have the last initial R, so that means there's a 5 here. And 28 have the first initial R, so that would be 22 right here. If you add this plus this together, plus the part that goes up to 100, you would get 67. So 67 plus this plus this plus this makes 100. All right? So it says if a child is selected at random, find the probability that the child has a first or a last. So first or last means it could be here, here, or here. You're just adding these together because that's R union, no, union, not intersection. So the probability of first union capital R. So you're just putting this here together. So that would be adding them together, a total of 33 out of 100 would be the answer to this problem. All right, the last problem before the assignment is an inspection, and we're going to make another. I think the easiest way to do this one is to make the other box thing again. We got this, and we got this, And it says an inspection of desks made at a furniture plant reveals that 2% of the desks have structural defects, 3% have finish defects, 1% have both. So 1% goes there. I should have done it backwards. 1% goes there, so that would be the 2%. And then this would be called structural. So STRUC. So that's a structural defect, 1%, 1%. And then finishing defects would go here, and that would be 2% because 1 and 2 make 3%. And so that's total of 4%. So this is 96% out here. All right. So we're doing this with percentages instead of actual numbers. Okay. Has at least one defect. So that means it could have one or both. So that would be this plus this plus this. That's 4%. And neither have a defect, and that would be 96% because that would be the complement of that. All right, so there's this lesson in 11 minutes. But the main thing here is that we can save ourselves some time by not just doing 1 woman, 2 women, 3 women. Figure out what the probability is for 0 women and subtract it from 1. And that will save you some time when you're doing these problems. Or you could do that plus that plus that, and you could check it out and see if it works the same. It also introduced the idea of complement, which is the 2 parts have to make a whole. And the idea of mutually exclusive is no overlap between the sets, and that affects probability.